Okay, good evening. Today we are going to present our Circuit Analysis 2 project, PTE 2232. My name is Kogulan Anarikiravi, TB 23012.
Good evening, my name is Dinesh Kumar, TB23021. Okay, this is introduction. Low pass filter is a circuit that allows low frequency signal to pass through while attenuating higher frequency signals. Filters are widely used in various applications, including audio signal processing, communication systems, and power supply smoothing. RC, which is resistor capacitor, and RL, which is resistor inductor. Low pass filters are two common types of passive low pass filters that achieve the behavior of frequency dependent impedance characteristic of filter and inductor. Next. Okay, objective of this project is first is the transfer function is developed for low pass filters. Second is the cutoff frequencies, right? The board plot is constructed sketches of the transfer function. Next is a discussion of the comparison between measure voltage, gain response, and the theoretical sympathetic response predicted by a Bode plot. Lastly, the voltage gain drops at the rate of 20 dB is explained for each frequency. Next. Okay, software requirement. In this project, three key software tools were utilized to ensure successful design, documentation, and presentation. Multisim, Microsoft Word, and Canva. Multisim was used for circuit simulation analysis, enabling us to test and verify circuit. Microsoft Word play for crucial role in the documentation process. And lastly is Canva for designing visual presentation materials. The component which we use for the project and component requirement is resistor 81 ohm, resistor 325 ohm, and wire jumper function generator capacitor which is 0.47 mF, inductor value is 4.5 mH, and we use oscilloscope and breadboard. So this is the circuit for RC low pass filter. At low frequencies, the capacitor has high impedance, so most of the input voltage appears across. So for the higher frequencies, capacitor impedance decreases, putting high frequency signals to the ground, thus attenuating them. Next. So this is the calculation we use for this project. This is the list of formula. So first we use RC low pass filter. This is the formula for RC to calculate the RC low pass filter. And this is the formula for RN low pass filter. And for impedance, there is two. First is capacitive reactance. Secondly is inductance. Then we use formula for voltage gain, which is UVDB. And for voltage divider rule, we have two out. And for phase angle, to calculate phase angle, we use this angle. For transfer function, we use V out over V in. And lastly, we use magnitude, which is TF. The formula, we use the for TF.
Okay, next moving on to our experiment output, which is for RC low pass filter. This is our results, amplitude and phase shift, SVC. We use the calculation cutoff frequency WC, and TF, output voltage VC. And as we can see, our amplitude is starting from 2.08 volt and it's slowly decreasing to 224 millivolts. And also our phase shift is changing from 71.28 until 74.16, our last value. Moving on to voltage gain in RC circuit. Voltage gain we calculated using dB. We use 20 log V out over V in equals to how many decibels. And also moving on, this is multisim simulation RC low pass filter. This is our simulation for 100 Hertz. And also this is our simulation for 10 kilohertz. Moving on, this is how we took our measurement for RC low pass filter. We use two oscilloscope modems, and also we use function generator with an amplitude of 4. This is how we plot our data for calculation. We use to plot data, plot in multisim, RC low pass filter AC suite. As we can see, the graph is decreasing. It will decrease gradually. It doesn't decrease on the spot, as it follows the lines, and also it will, until when we reach a certain frequency, just like 100 hertz or 1k hertz, it will decrease. And moving on, this is the calculation we use for RL low pass filter. We use cutoff frequency, output voltage, transfer function. It is quite the same as we use for the other calculation. And this is our result. It started on 1.7 volts, and on 10 kilohertz frequency, it ended on 1.24 volts. And also for the phase shift, for the first 100 hertz and 200 hertz, we got zero phase shift. And moving on, we had different phase shift. Okay, this is voltage gain in RL circuit. We use the same formula for voltage gain, 20 log V out over V in. And this is how we gain our RL low pass filter circuit measurements. We use the breadboard, and also we use the same method, same amplitude. This is our multisim result for RL low pass circuit, 100 hertz. And this is our result for 10 kilohertz.
Okay, for discussion, the behavior and characteristics and RL low pass filter circuits analyzed through the development of transfer functions, determination of cutoff frequencies, construction of both plots, comparison of theoretical and measure response. And the cutoff frequency for both was defined. Output voltage dropped to 7.7% of the board plot graph show flat pass band and linear decrease in gain and stop band. Lastly, despite theoretical and measurement aligned closely with minor and tribute dominance of relative component, overall, these experiments valid with the theory of low pass filter into their design. And next, so for voltage gain, we analyze the voltage gain equal to AV equal to out over V in for both RL circuits across various frequencies. So for the RC circuit, the voltage gain significantly decreases as a frequency increases, showing a clear low pass filter behavior, which is allowing low frequencies to pass, while higher ones, this is due to the decreasing capacity taken at higher frequencies. So overall, both circuits demonstrate frequency dependent gain, with RC acting as a more pronounced low pass filter. So for conclusion, a low pass filter allows signal with a lower frequency while preventing signal with higher frequencies. Secondly, these filters permits the frequency components of the signal to be smaller and the signal cutoff range. And the low pass filter gains varies inversely with the frequencies. Lastly, despite minor discrepancies due to real world factors, the alignment between theoretical and cost analysis. Next.
And that's it for our
So
presentation.
that's all from us. Thank you.